Hey class. Hey Anselmi.
Hey Louis.
Good. We have an interesting demo today. 2 balls, 2 collisions. What do you think?
Well, that's cool. So what we see here is we have a little bag full of sand, and here we have a bouncy ball.
Okay. Question is, perfect. So we're going to raise them both to the same height. Let them collide with these essentially identical wooden blocks. Which one do you think will transfer more momentum to the block? This is a collision. In a collision, there's an exchange of momentum. Which one will have the biggest exchange?
Well, okay, I think that the collision with the bouncy ball will be very elastic.
Yeah.
On the other hand, for the bag of sand, that will be a kind of a sticky collision.
Yeah,
inelastic.
Inelastic collision. Good.
So from that, I would say that the bouncy ball should be quite elastic, and so should have a bigger transfer of momentum.
Okay, I'm not sure that's completely obvious. We'll work it out on the board, but let's check first whether your intuition is right.
Okay, let's try this.
Ah,
Look at this.
I think you're right. There was a bigger transfer with the bouncy ball. All right, but let's work this out. I think why is that the bouncy ball was a bigger transfer? So we're just looking at change in momentum, right? So let's call this the x direction, and with right being positive. So then I can write the exchange momentum. So what we're looking for, delta px, p final x, p final x minus p initial x, all good. So then if you look at, so we have the white and the black. So, all right, so what is the p initial? So they're gonna have some p initial, essentially the same for both.
Right.
Right. What's the p final for the white?
Well, the P final for the white, since it's a very inelastic collision, it will be 0.
Perfect. That's right. What about the black?
The black, on the other hand, since it's an elastic collision, will have minus P initial.
Just bounce back with the same speed. So then it's in the negative direction. So we're going to minus p initial. Great. All right. So then I can just do my delta p. Delta px here is 0 minus p initial x. And for the black, the final is minus p initial x minus p initial x. That's going to be 2. So minus 2.
So as you can see, the momentum transfer is much bigger for the black ball than for the white one.
Yeah, by about a factor of 2. It's a negative exchange of momentum. So this ball is losing momentum, giving it to the block. And this one gave twice as much block momentum, which was enough to tip the block over, while the white was not able to. The thing with momentum is always be careful with your sign, because it's a vector quantity. That's a demonstration for today. Thank you, class, for your attention.